Now, there's one thing that you could think about. So, as when you are sending information from the sender to the receiver, you may be wondering where to do this encryption, or at what level. Do we need to do at every link like this I have shown here? So, this is the sender, it goes through some intermediate routers and then reaches the receiver. So each router has to do the encryption and decryption, or it could be done at all the encryption could be done at the source, the sender, and the routers don't need to deal anything with the encryption decryption. They just forward the encrypted message, and the receiver does the decryption. Now, if you look at the pros and cons, the end-to-end encryption has a lot of advantage with it. So the main advantage that comes with what's called end-to-end encryption is that all the routers need not be worried about maintaining the keys at every level. So in order to understand the pros and cons, let us go through first the link encryption. That may be better. So with link encryption, the routers need to handle encryption. So that means every network has to have a router that is capable of doing encryption, decryption, and also those routers need to share the keys with the routers in the adjacent networks. So if you think about a sequence of networks where the message has to be transmitted, so this router has to maintain a secret key with the router corresponding to the sender's network, as well as a secret key with the next hop router. And this one has to maintain the secret key with this previous router as well as the next hop router, and so on. And not only that, how information could be transmitted is like this. So the sender at the application layer will set it as a plain text. So then the message is really encrypted at the physical layer, and then so only the hardware address of the sender and receiver, the immediate sender and receiver, is exposed in plain text. The rest everything is encrypted here, so that the router could only get the message and process it using the receiver's hardware address. And then in order to decide what's the next hop, the router should do the decryption and look at the network, the IP header, and see what's the destination address. So the router should be able to see what's the destination address. So that's why you don't encrypt any of these headers and the actual data. You cannot encrypt them because routers need to be able to look at the IP address of the destination to decide the next hop. So that means the router should be able to decrypt the message that was encrypted for transmission. So with this idea, you want to prevent someone from hacking the channel and seeing what is the message. So you do the encryption, but only at the physical layer. You encrypt the whole message so that nobody else can see. But the routers have to decrypt the message and look at the IP header. So that way you are again exposing the message at the router. So the router could see what the actual data is that you are sending. So in case a router is compromised with an attacker, then the attacker gains control of the router and will be able to get all the messages that are forwarded by the router. So that's not a good thing. So that's why link-to-link encryption is generally not a preferred technique, both for like potential loss of confidentiality as well as the scalability of this idea. So by scalability, I mean every network needs to be having routers that are capable of doing encryption, decryption, and they have to share the keys with the adjacent routers and adjacent networks. So there's a lot of overhead. That's why we prefer end-to-end encryption, where the application running at the sender is really taking care of all the encryption overhead, and it's only the data that needs to be really encrypted, the message that you really want to send. So the headers could be still left in open in plain text. So it's just encrypted data that could be forwarded by the routers. And you don't need to really do encryption of the IP header, and the routers can look at the IP header and just decide the next hop. So this comes with a lot of less overhead because no network requires routers to be able to handle encryption, decryption, and also has no need to share keys with adjacent routers. The only overhead you can think about is the everything is need to be taken care of by the actual end users. So with the link-to-link encryption, the end users do not need to worry about encryption decryption. They do not need to worry about sharing a secret key with the ultimate receiver. Whereas with this method, it's end-to-end encryption. So that means the end users need to worry about sharing the secret keys and so on, which is not big that big of a overhead, but it's still you need to have secret keys for any two users that should not be known to anyone else. So that's the kind of comparison between the two techniques. Okay, so this could be there could be some questions like on this topic in a quiz, which is the final exam is going to be like a quiz. So there could be some true or false questions based on the advantages and disadvantages of these things. Okay. Any question on this?